Okay. All right. Let's
You're
kick it
not
off.
sharing.
So,
You're not
oh,
sharing.
oh, really? I'm sorry. My mistake. My mistake. Do you guys see it now?
Yep.
Yeah.
Amazing. Amazing. Great. All right. So let's kick it off. Today we talking about innovation projects, and specifically, as you will see, we want to compare it between the traditional projects in traditional sense that everybody knows, and the innovation projects. Why one doesn't work for, why they different, and why it's important to have both of them. And usually we starting with a quote. Every presentation that we have a quote. And in this case, it's innovation is a change that unlocks new value. And that's very important to understand for this upcoming presentation and upcoming talk. Oops. So first of all, let's dive into definition. And definition of a project. Very, very general definition, a pretty good definition. It's a project, it's a time-bound initiative designed to develop a distinct product, service, or outcome, right? It's great. It's a great definition. Everything's fine here, but there's two different types, right? One is a regular project. It's basically a predictable outcome where we have a clear objective, clear goals, very structured plan, like building a house, building a piece of software, getting to that goal by executing these tasks. And then there is an innovation project. Innovation project, it's usually uncertainty, a lot of uncertainty. We don't know, we usually know where we want to get to, but we don't necessarily know how we're going to get there. And it does require experimentation and, of course, a lot of problem solving at the end. And the examples of that going to be R&D. We basically exploring what is it we're going to do, how are we going to achieve that, what kind of problems we're going to see on the way. And another example of that, as written here, it's a disruptive product development. Right. So just to summarize, the key differences between the regular traditional project management and innovation project, there are a few key things. There's probably much more to that, but we wanted to focus on these things. First of all, the goal. The clarity of the goal in a regular project, it's usually well defined. Again, as an example, it's building a house. I want to finish building the house or constructing a car, whatever that is. Where innovation project is often very evolving. We have a kind of a guidance where we want to get to, but what's going to be the end goal? Usually we don't know, right? Process in a regular project, it's a very structured, usually very linear. In some cases, of course, we have parallel things, but it's a very well-defined list of things that we need to execute in terms of tasks in order to achieve that goal. Where in innovation or in R&D, as you can imagine, it's very iterative, very flexible. Sometimes we have a very particular plan, and then we explore something and we understand something new and we change that plan very quickly. Now, risk and uncertainty. The goal of a regular project is to reduce the risk. So we're trying to strive to reduce risk. And this is why we're planning a long time beforehand, and we make sure that everything is executed on time. So we're trying to make everything predictable, right? Where innovation is, by definition, we don't know. We can't predict everything, and the risk is high by definition. And this is our mindset. The risk is high. We don't know what's going to be the full outcome of that, and often, as we said already, the goal as well. So it's more of an exploratory work. And of course, the approach. The approach for a regular project is a very execution focused. We have a list of tasks. We have a goal. We need to go through these tasks. We need to make sure that they're done on time. Everything needs to be executed. And then if it's executed as planned, everything is going to be fine, usually, right? Where, again, back to the innovation project, the experimentation is experimentation based. And again, we don't know where is it going to end. We experiment, we learn something new. It's very learning driven approach, right? We explore something and then we move on. And many times we We have some predictable things that we thought that they're predictable and we want to go to them, and then eventually we drop them completely because they becoming not important, right? So in general, managing the innovation project like like a regular project, and this is what a lot of people actually trying to do. For example, use Jira, which is a perfect project management tool to manage innovation initiatives, which is not really working well because it's based on the fact that you have again a very specific plan, very specific list of tasks, and it falls short on the actual need for the innovation project. Now, let's dive into the why again, into the more details. Why the traditional project fails for innovation, right? Again, fixed plans don't work for innovation. Just period, end of story, right? We need flexibility for innovation where the traditional project don't provide that. Efficiency versus exploration, right? So for traditional project, we want to focus on efficiency. Everything is executed on time. Everything is predefined ahead of time. We know what to expect. Where in innovation, it's more, as we mentioned, it's an exploration. We want to try different things. We want to explore, potentially even come up with new ideas on the way. Explore and understand which problems we're going to hit on the way, and so on. Predictability, that's just, a natural continuation from that. So again, regular traditional projects, they supposed to be very, very predictable unless something unforeseen happens. But the goal is to make it unpredictable. In innovation, you can't have that goal by definition. It's uncertainty, you're diving into uncertainty, and this is why you're doing that. The risk, again, in traditional projects, we're trying to reduce risks. That's one of our main goals in traditional project management, because, for example, we have deadlines to build the same house or to construct the same car, and so on. We have deliverables that we have to stand in at a particular time, right? So there's a lot of risks involved, but we're trying to reduce risk. But that fact actually kills creativity. And in R&D and innovation, we have to embrace creativity. So we need to do completely different things. And execution versus discovery, of course, it kind of between the lines everywhere. In here, traditional methods, it's focused on execution. Here's the list of tasks. Here's the plan. We just need to execute and make sure that everything is done on time without hiccups. Where innovation and R&D, it's more of a discovery. We're actually trying to understand how things potentially going to work in the future. All right. Now, let's dive more into what's actually needed for innovation project. As we mentioned, flexibility over fixed plans, right? Innovation does demand for a more iterative approach. We need to allow ourselves to be iterative and potentially agile versus the step-by-step execution, right? Creative thinking and problem solving, extremely important piece. It's probably, in my mind, it's the central piece of any innovation and R&D work. This is where we generate the new ideas and generating new ideas, fighting the problems in order to actually execute them and make these ideas a reality, right? Embrace risk. Everybody talks about risk for innovation. What does it embrace risks, right? So we have risks, especially in innovation projects, and experimentation is part of it, but we need to be able to what we call here to take calculated risk, and it means that we know how to deal with these risks as we go in, as we dive into this unknown, right? Structured, we do need structured methodologies, right? But these methodologies still need to be flexible enough to adapt to this agility and to this to everything that we talked about until now. So innovation does innovation still needs the tools and the methodologies to make it a reality, because otherwise we're just going to be running in all directions and not achieving any results. And this is basically why we do it, why we do what we do in PRIZ. And PRIZ Platform's advantage is actually providing these methods and structured thinking around that supports all this agility and risk management within the innovation project. Again, the standard, the traditional project management is not going to work here for innovation initiatives, because what we talked about here. And the PRIZ platform actually supports the methodologies, the tools, and the processes to enable this structured thinking for innovation and make it effective. Anatoly, do you want to add something in here?
Yeah, I would add about risk. I don't remember who said it. The highest risk may be not to take risk. This is one thing. Another thing, a regular project requests some operation, some sequence of operations, and innovation project requests sequence of thinking. And this is what, that's why you cannot use Jira or MS Project for innovation project. You will kill it. No,
yeah.
Thank you.
Thank you. Right, and last but not least, innovation in general requires a scientific approach. Like anything that we do out there, it's based on science. The innovation is a science as well, and problem solving is a science as well, right? For example, you can't, you can build a house by putting brick on brick and building a wall. That's not a problem. You don't need to understand the mechanics and the physics and the chemistry behind why these bricks hold together. That works great for a regular traditional project. But in order to develop the concept of how you're putting these bricks together and how they're going to be holding, you need the science. And again, the innovation and problem solving is a science. It's been taught for many years and been studied for many years. And the scientific approach just yields much better results from that. Ensures the problem analysis properly, because again, it's backed by science. It's been studied for many years. Reduces uncertainties and so on. So PRIZ platform supports that entire scientific workflow, if you will, to enable us to enable the scientific approach. So in PRIZ, like we said here, innovation becomes not just an idea, it's a scientifically backed process. And this is probably the most important thing. There is a process, and it's very important to have that process in place to have the structured thinking. And this process is supported by the PRIZ platform. I'll pause here for a moment before we dive in. All right. So, do you still see my screen?
Yes.
Right. So we talked about the thinking process, right? And the entire platform that we built here and that we continuously developing is built on the fact that we forcing people to think instead of execution, very step-by-step execution. We're forcing people to think, and it starts from a very, very beginning, right? First of all, some of you know the platform is organized in form of projects, and project is it could be a 5 minutes project, it could be half an hour project, it could be 5 months project. Right? It doesn't matter. It's still a project. It's still this structured bubble of all of our knowledge that we gathered within this project, with our unstructured process, right? So it's an unstructured process, but we're still forcing a structure into that, the structure of thinking. That's very important. So again, as I mentioned, it starts from a very beginning where we need to even define where do we work? What industry are we in, right? And let's say we are in semiconductors manufacturing, right? So in here, I don't have the semiconductors. I can ask a little bit of help here. We build microchips, right? And it will basically, here you go, semiconductor manufacturing. So let's go with that. We can talk about quality assurance, let's go with quality assurance, right? So again, we forcing ourselves into a specific zone that we work in, the department that we work in, then that's going to be the goal, right? Increase efficiency that's fine, increase efficiency, but it doesn't matter at this point for this demo, but it is extremely important to understand what is our high-level goal, because from that high-level goal, the platform will start forcing you to focus in and zone into the specific zone of conflict.
Hey,
right?
Alex, on your goal selections, when you go back on the previous screen that you just looked at, can you only select one goal or objective at a time, or can you select multiple?
Yes.
Let's say, for example, I want to do increase efficiency, but at the same time, I want to improve quality as well. Could you select both at the same time?
You don't, and there is a very good reason for it. Basically, when we're trying to innovate or make a change or achieve a goal, usually it's a single goal. If we're trying to achieve many goals at a time, you will end up with a mess, right?
Okay.
Now, what could happen potentially, you saying, "Oh, I want to increase efficiency," but by increasing efficiency, and many times we do that. Oh, we need to reduce costs. Let's fire a bunch of people, right? But what does it cost you? That layoff, it can cost you problems down the line, right? So the idea behind the goal is that you have one particular goal at a time, and that's very important to have in mind all the time. Eventually, you might deal with a bunch of different other problems that coming out of it, but the initial goal has to be a single goal. Again, focus.
So if that's case scenario, then if you had, let's just assume that your efficiencies are not good and you want to, of course, increase those. But I say assume in the same department that you're suffering from quality issues. So would you then have to do the same interactions again, start from, semiconductor, whatever, and go through the same process? So you have multiple projects, I guess, but each one of the specific goal, right?
Right. It's a different problem to solve, right? And
Yes.
you probably heard it from many meetings in your professional lives where it's like, hey, what about this? Yeah, it's a different problem to solve. It really is. It is a different problem to solve, right?
Yeah.
We might be able to address it as part of the same project, right? But that's it down the line. The goal needs to be very, very specifically defined, because otherwise we go in different directions completely, and it just diverges, right?
Gotcha.
Now, from a challenges perspective,
Alex,
yes.
may I make a comment in this gentleman's thinking? What I found over the years is the most important thing is to really define the situation or condition or whatever you're working on. Because if you don't do a good job of defining what you're trying to do, you're going to go off in directions that are going to be wasteful and non-productive. So you can't, from my experience, you can't have an increased efficiency and increased quality at the same time. If you want to increase efficiency, you have to say, I want to increase efficiency of what? Not just a broad-based thing. Because increased efficiency, you're all over the ball field. But if you have a specific thing like I have a certain machine and the productivity of that machine is not to the level I want, then that's my efficiency or productivity question, rather than I have a lot of machines and I want to increase the efficiency of all of them. You don't know where to go.
And
Does
you're
that make
absolutely
sense?
correct. You're absolutely correct. One of our next steps, where I'll get to that in about 2 minutes, is exactly about that. Is defining in very high details of what is it your project about? That efficiency. What does it mean? Efficiency of what? Exactly like you're saying. Right. We'll get there in just a moment. Okay. So again, in here, the platform forces us to define a high-level challenge, right? Why is it we even here? What is it we're doing in this project? There are a few options. We can write it ourselves, or we can select from a couple of things that machine proposes. Usually, this piece is done to get your wheels going, and not necessarily like specifically give you an answer, but it gets your wheels going in terms of what is it you're going to do, what is your real challenge that you're working on. And again, just for the sake of this example, for this demo, I'll just select one of them, just not to waste time. And one of the things that the platform does is, first of all, validates, right? Because we've seen many examples where people gone into the project and just test, and they didn't see the value in that at all, right? In that test really, like in any innovation project, you can write tests on the tasks and see how they work, right? When you have a predefined task, but when you don't know what you're doing, and you have potential high-level goal in mind, then the test is not going to work. You actually need to start engaging your brain into that, right? And that's one of these steps. So let's give it a title, improve efficiency of our process, and we'll kick off the project, right? So everything that we fed into the system until now, it's all here. And the piece that you were talking about, David, is exactly the project background. This is everything that we know about our goals. This is where the exploration work starts. We need to understand what's the goals. We need to understand the current situation. We need to understand the system that we're talking about. Everything that we know about this problem space and about our system, right? And one of our things that again the system helps us to do is to do some evaluations. And in this case, the evaluation of this single sentence in there, of this single sentence, is it gave a mark of a 10%, right? It's basically not enough to continue forward from the machine perspective. Even the machine can understand that it's not enough, right? So it gives that completeness percentage and do some evaluation, and also provide some high-level suggestions of where to move next, what information is missing, what should we dig up more and provide more information for, right? So in this case, high-level system description. Realistically, we don't have that, right? Includes specific challenge symptoms, like what's happening, why are we even doing what we're doing, stakeholder inputs. And as we go and develop this background, it will help us to dig for more and more details. Just for the sake of time, I'll just copy one of our existing projects in here. It's a real case study from the past, and we can run this evaluation again, right, and see how the system reacts to that, right? So now you gave a completely different completeness percentage, right? It's still not perfect. We usually trying to push people towards the 75%. This is when the this bar becomes green. It's extremely hard to get to 100% as you would expect in anything that you're documenting in a regular Word document for these type of projects. Of course, it's very hard. Everybody who reads it will find something missing in there, and that's normal, and that's okay, right? And again, additional details that it suggests to add and so on. So that's the project background. This is, yep.
Another question or comment, Alex, is when you're
Mhm.
building this, it would be a very good idea to have different stakeholders involved in the issue that you have, because what
Right.
I'm finding now is you can't know everything, and if you have people in, for instance, quality control, production, engineering, all like that, helping to define, make this definition, you will come up with a better definition in the long run. That's
Absolutely. Absolutely, 100%. It's a collaborative exercise. It's very important to have multiple people from different departments, from different even mindsets, to be contributing to this, and actually throughout the entire project, right? We, just as a side note, we had an experience with one of our clients. They had marketing in their department, marketing in a room as part of this initiative, and it was amazing. Why? Because even the marketing perspective was very important when they were trying to solve a particular problem. In that case, they were working on new product development, and a marketing girl at some point she said, "Well, it's all great, but we won't be able to sell it." Right? So it's these different perspectives, and an organization or company, it's a group of people for a reason. This is not an exception. All right. And what we're allowing to do here is a team project, and that also helps to get more stakeholders in and understand who is contributing to this project and how they contributed and so on. All right. Any questions here before I move forward?
Right. Yeah. May I ask one?
Of course.
Thanks. Well, you defined that your project in general have the one main goal, right?
Mhm.
And what we're gonna do if we will have few project goals, as usually happens? How we can say set up interdependencies in your cases between the projects?
So there is no capability in the system currently to set up interdependencies or
Right.
blockers or something like that.
Mhm.
I mean, it could be described anywhere, but we still see it as a completely different, distinct initiatives. They might be related. They, from a managerial high-level perspective, they might be related, and it's all under the same roof. It could be the same budget, of course, but it's two different initiatives.
All right. And for resource buckets, say that can we share resources between the projects and something like that? So I going from traditional project management.
Exactly.
Yeah.
Exactly. We basically not concerned about that. This is not the problem that we solve, right? We solve the problem of a structured thinking. This is very important. Structured thinking, structured approach, scientific approach to problem solving, or quality improvement in this case, right? Who works on it? What type of resources?
So it's out of scope.
It's out of scope for us.
Right.
Like we love to say, it's a different problem to solve.
Great. Yeah, thanks.
Hey,
Right.
Alex,
Yes.
when you're doing this, would this be a good time to do a preliminary functional analysis, or would that be left till later?
Can you clarify the question?
I'm saying you have a on the screen a photograph here of what's going on. So, and you say the WIP process is doing something.
Right.
Would it be helpful to make a simple diagram or preliminary functional analysis of what's going on to see if you are defining the problem specifically enough? That's what I'm saying. Do we do it
Sometimes
now
it
or do we do
does.
it later?
Sometimes it does. Remember what we talked about unstructured exploratory work, right?
Right.
Yes, we're proposing a structure and kind of a flow inside the project, but there's nothing stopping you from going to the tools, and we will dive into them in a moment, going to the tools, using one of the tools, for example, functional model, for this case, exploring your problem space to even define this background. It's absolutely helpful sometimes, right? Again, I'll give an example. Yeah, sorry.
So, well, when I'm seeing the problem being defined here, it in the back of my mind starts to point me in the direction of what tools I will need to solve the problem.
Of course.
But we haven't defined those tools yet because we haven't finished the problem statement yet.
True. It's a contradiction. You can say it's a contradiction, right? We want to not to enforce, we want to guide through some sort of process, but leave it unstructured, right? So it's a little bit, we probably need to work on the UI elements and the fact that we, yes, go ahead and use the tools. But technically, nothing stops you from going here and using any of these tools at any moment in time, right? So if it helps you, and if it helps you to, if any of the tools helps you to define this background, or as we've seen a couple of examples, again, with one of our clients, they use the cause and effect chain, for example, to come up with a proper problem statement, right? Absolutely. There is nothing wrong with it. Again, part of that exploratory work that, yes, there is some sort of structure of thinking, but our thinking by definition is unstructured.
Okay,
right.
Thank you.
Yeah, for sure. So going to the next step here, once we have the overview and we have at least some level of understanding of our goals, what do we have, which systems we're working on, and potentially even some high-level description of the actual problem, now we need to define the problem statement. Again, something that the engineers hate doing. They don't want to do that ever because it's boring. So we try to make it a little bit more fun. And even here, we define the process of how you define that. Now, of course, we have, as you're starting to see, we have a lot of different places where AI helps us. We need to treat it as a help, as a guide, not, God forbid, not a set in stone piece of information. It gets your wheels going. It's something that how we love to say it, fight with the machine, right? Like you fighting in other people in the room that have a certain idea. There is no problem with saying, hey, you're wrong, or something, we have a different idea. Same thing here, it's a conversation, right? And in this case, this conversation starts with defining what's the current situation. And the current situation, it of course uses the overview here, defects have been observed on the wafer, and so on, so on and so forth, right? For the sake of saving time, I'll just use that. Again, maybe I'll just delete a piece of it just to make it shorter. So that's the current situation, right? The next step is, what's the disadvantages of the current situation? We went through that before, but this is a very important piece. Again, we don't have any tasks to understand it. Again, if we compare them to traditional project, right, we would be all the way here. We need to define problem statement. But how do you define that? What does it mean? What's the steps to go through? Nobody knows, right? So this is where we're engaging the thinking process into them. So disadvantages of the current situation, right? It could cost money. It could we could lose clients. We could do there's a bunch of different disadvantages, or why is it bad kind of problem. So, and this is where we potentially seeing one symptom. So you can treat the current situation as a symptom, and the problem that it causes, it could be multiple different problems, right? So for example, we will choose one of these. Again, please fight with the machine. Machine is not always right. It just gives you some hints. Next, the ideal final result. Where is it we want to get to, right? Perfect wafer, no defects. Yeah, I think we're talking about the defects on the wafer. Yeah, the perfectly clean wafer, for example, right? That's the ideal final result. Usually machine is very poor performing here because it doesn't know what you want. It doesn't have your brain. It doesn't have your context. It doesn't have your emotions as well. There's a lot of emotions in these projects. But again, I'll save some time. Achieve defect-free wet cleaning process with zero rework or scrapping of wafer. It's actually pretty good, right? And so on. Gaps. It's another thing. Why is it, we want to achieve a particular final result? Why can't we do it right now? Why can't we just snap fingers and get there within, 3 seconds? There is a reason for that. There is probably a bunch of different reasons for that, because the process is imperfect, because whatever else is out there, right? Lack of real-time monitoring. Maybe this is where we need to engage our brain, the system consistently asking us to think. Yeah, I'll just select a couple of these two. And finally, when we have all of this information kind of organized in our brain and in front of our eyes, now we can define the problem to solve. And the problem to solve is just one problem at a time. Same as we have one goal to achieve, we can solve only one problem at a time. We could be lucky sometimes, and we could be potentially solving, killing 2 robots in one shot. But that's an exception rather than a rule, right? Again, one single problem at a time. Again, I won't even read into that just for the sake of this, saving time. But eventually, this is going to be the problem statement, and this is what focuses us, our team, anybody who works on, stakeholders, anybody who is involved in this project, of what is it we're focusing on, which problem are we going to be solving.
Alex, may I interrupt you for a
Of course.
moment? Yeah,
of course.
I think even on this step, you may have some ideas, and you have very nice button idea to document this idea, and it will be saved in the idea manager. You also can generate task to ask John bring 3 kilograms of nails, and he will get email with a due date, and you can generate meeting. You have buttons for this.
Yeah,
nothing.
I wanted to get to these things a little bit later, but yeah.
Yeah, I just wanted to mention, which is important, nothing special with tasks and meetings, except one thing, that they all will be saved within the project. You don't need to look for in your Outlook which email, which meeting belongs to which project, which target. It's acceptable for a regular project. It's not acceptable for thinking project, for innovation project. Yeah, sorry.
So one thing, I'll expand on these things. First of all, again, going back to the unstructured thinking and unstructured almost anything. Sorry, unstructured process, but still structured thinking. My mistake. While we work and even gather information, ideas can pop up, as Anatoly is saying. So we're recording them here, and let's just record it. Oops. Idea 1, whatever. I won't even dive into that. So that's recorded in Idea Manager, and I'll show that in a moment. Tasks. We talked about, there's no tasks in Innovation Project. Well, yes, there is. Because if we in the process we define that we do need to do something to continue forward, it is a very well-defined task, right? Like bring a kilogram of nails or do some measurements or do whatever. It is a very well-defined task that needs to be executed. So there is some correlation between a standard project or traditional project and innovation, but this is the only place where it correlates. When in the process we define that we do need to do something, but that's about it, right? And then meetings, of course, any of these initiatives is usually a cycle of meetings, tasks, and meetings and tasks and exploration, right? And this is why we allow them to create these meetings, and I'll show that in a moment if we'll have a little bit more time. Any questions about this? All right, let's move on. So, tools. We have today 12 tools. One of them is not released yet. We're still working on it. It's still in progress. But we have today 12 tools, 11 released. And each and every tool is built for a particular purpose, right? For example, for the inventive principles, it helps us to break through contradiction, a very particular contradiction once we find the contradiction and find innovative solutions. A round-robin ranking, make a choice or make a decision between multiple different options, because we as human beings are not capable of doing that efficiently. Again, it's trying to make a completely inefficient process a little bit more efficient. Urgency, importance, prioritize tasks. Apparently it's not that easy, because if we have a huge list of tasks, it's actually very complicated to do. So just cognitively thinking about that. There are a couple of known, very well, popular tools like 5 Whys and cause and effect chains. These tools more for root cause analysis. One is a linear approach for root cause analysis. Another one for like a ramified trees when we're building that. Action preventing action is actually one of our own homegrown tools to find what customer needs. We have a webinar about that, and we'll probably expand it on that a little bit later. Effective brainstorming. Now, brainstorming is something that we have mixed feelings about that. Brainstorming is by definition unstructured thinking and people just throwing ideas around, which is not very good, but not very effective. But we added an additional process into that to make it a little bit more effective. And people do feel comfortable with the brainstorming, just throwing ideas around. But the question is, what do you do with these ideas after, right? So that's effective brainstorming. 9 Windows. It's an amazing tool where you can potentially predict the future based on the current system structure. And so it's a thinking in space and time. You're breaking your system into component, subsystem, super system, and it helps you to think what's the next step and what's the next step in evolution of that system. Perception mapping allows us to find blockers in anything that we're trying to do. For example, we want to achieve a particular result. There's a bunch of different steps that we need to do. What is blocking us from achieving that? That's the tool to do that. Functional model, and of course, process functional modeling. This is one of the, two of the most powerful tools in the system in this methodology in general. And that helps us to model a particular system or a step in the process and to understand how it works, which components involved, which functions is there, which components potentially create the problems that we're seeing. For example, the inefficiency. So these tools, they very similar in concept, but the process functional modeling focuses on a high level process analysis, where the functional model on a particular step in the process or one system and so on. And change flow thinking, it's to understand the risk in the changes and how do we reduce them, what does it mean? So it's again exploring what happens if we're going to implement a particular change, what's going to happen after that. Okay, now system here as well, saying okay, what's the best? Because next question is what's the best way forward? Like David mentioned, we might already be thinking about which tools to use to help us with different things. The system also helps us to identify which tools to use. In this case, even provides a little bit of explanation why this particular tool might be useful for our use case, right? And I won't dive into tools specifically. Any questions here?
I would be curious if you picked, for example, the cause and effect chain for this particular issue.
Mm-hmm.
Is the system able to give you some probable causes to the scenario or to what is contributing to the problem? Or
The system itself will not, but
okay.
with the system will guide you in your thinking
Mm-hmm.
to get to that point. That's very important to understand.
Right.
Again, the system doesn't solve the problem. The machine
guys-
cannot solve the problem. What the machine can guide you, it can organize the thought process 100%,
Mhm.
but it can't solve the problem for you. You are the one who is thinking.
So if you
Right?
select that cause and effect chain, then does it still
It,
guide
it,
you
it
on
just
the
kicks off.
probable? Or
It
it's
just kicks off the tool. It
okay,
kicks
got
off the
you.
tool where again it forces us to document
To think
what is
okay,
yeah,
got you now.
what is the subject that we're trying to analyze, and then we're diving into the diagramming itself and what's the conclusions from that, right? So that's the thinking process. Like you would say, oh, I need to analyze. Why? What is it I'm trying to analyze? Great, I understood that. Now it's my analysis itself, the diagramming, right?
Okay.
Potentially multiple people doing that. And then, great, we uncovered something new as part of that process. Here's the conclusion, right? So it's always that process.
Right.
Okay. So creative thinking tools, it could be multiple. There's no limit of how many we use because again, we don't know how many we might need to use as part of any project. And as we mentioned before, in the process, anywhere in the process, we might generate ideas. And all of these ideas, they land in here in the idea manager, right? I'll actually use this example with the idea manager because we generated a few of them here, right? It's since it is a real use case, a real project, here we generated a bunch of different ideas, some of them good, some of them not, some of them being implemented, some of them being taken forward, and some of them ignored. The important piece to understand, even in the simple thing as idea, how do we evaluate the idea? We providing additional tools. How do we manage that, right? So again, different team members can go ahead and rank these ideas and saying, okay, with this idea, we're gaining that these things, and the cost potentially of implementing this idea is such and such, and the risk is such and such, and everything is documented in here. And if multiple people contributing into this, like here, well, this was just an example, then it's all calculated together. And that another tool that helps us think about which idea to take forward and which not. Because again, different people in the organization, managers might say, hey, we care about the cost, or we care about the speed, and the engineers care about something completely different, right? So this is where all people coming together and say, okay, out of all of that, we're actually going forward with whatever, this and this, right? At the end of the day, what is it we want to generate? We want to generate the final solution, the proposal for the final solution, right? And the proposal for final solution, it's not a single idea. It's almost never a single idea. Sometimes it is, but it's a combination of all the knowledge that we gathered until now inside the project. And now we can compile the idea. So usually it would go into the presentation or some sort of Word document or somewhere, right? In this case, it's compiled as a focused screen just for the solution that we're trying to propose. In this case, it was a short-term fix versus long-term solution, and so on. There is no particular structure in that, as usual. The last but not least is the report. That's another thing that engineers absolutely despise of doing, is reporting that. They worked
Excuse
very
me,
hard
Alex.
on something. Of course.
Yeah, could you go back to that previous slide? You have a photo of a shower head showering down
Yes.
here. Have you ever looked at a fractal distributor to do that? Or you know what a fractal distributor is? We can talk
So this
offline if
one,
not.
yeah, but this particular one was purely to emphasize the concept, right?
Okay.
How is
Okay.
it implemented? It's a different problem to solve down the line. But the idea, instead of having a single nozzle distributing the chemistry, or water in this case, it distributes across the entire surface, right? And I believe this is the one that was actually implemented eventually.
This is one of my ideas, like Anatoly put in. That's all.
Yeah,
Thank you.
of course. Again, it's what we're documenting and what's really is out there. Eventually, it could be potentially different, right? And we can potentially uncover a bunch of other problems on the way while we implementing something like that, of course. So going back to the report, usually people will do very dirty work unless they absolutely love it to generate the report. Here, you don't need to do that. Everything is done for you from the background information to the current situation, everything that we generated until now, the winning ideas. So winning ideas is the ones that we selected, and we decided, okay, these are the two that we're going with. The final proposed solution that we just looked at. But it doesn't end there. We're actually documenting each and every step in the process, which tools used, who used them, which ideas got generated as a result of that. So it's basically a fingerprint of the entire project. Who did what? Why did we come up with a particular idea? What triggered us to generate that idea, right? The entire thought process is documented here. And there are two benefits in here. First, of course, the fact that everything is documented. We can look into that 5 years from now and understand why a decision being made, right? Of course, that's very important. But there's an additional benefit. It's a fingerprint, as I mentioned. And fingerprinted means that it's a document that proves that you or your team or your company is the one who did this work and came up with this idea. What does it mean? From a legal perspective, from a patentability perspective, first of all, if you decide to patent it, it's already a big step forward to say, here's all the work that's been done, this is why, and that's the outcome. But also, if somebody else in the other side of the world comes up with the same idea and patents it, if you have the proof that you came up with the same idea before the patent took place, the patent doesn't apply to you. Okay, that's a very important piece to understand. So it's basically everybody else will pay for that patent, but you won't. Just looking at the time, we have a couple of minutes left. Yeah, I will stop here if you have any questions.
I have one
All right.
question, Alex.
Of
Back
course.
in your tool selection,
Mm-hmm.
one of the things that I did not see was perception mapping. Is there a particular reason that was not included in the creative
It's on there.
Oh, I'm sorry, I just didn't see it. Thank you.
Yeah, it's on there. It's actually one of our, I think it was a third tool that we built.
It's a very good tool.
Yeah.
Yeah.
Excellent.
Yeah.
By the way, you have a button, learn more. You click it and you can read the good explanation, each tool.
Yeah, every tool will have a fairly decent documentation, and we're trying to keep up with the documentation to make sure that it's up to date and how to use it and what's the outcomes. And, you know, basically the best practices for these tools, and every tool will have a page like that, right? Detailed explanation of a tool usage. Now, there's a lot of other resources in the blog articles. For example, if we search here functional model. Oops.
No, it's
Yeah.
subscription. Yeah.
Yeah. Good point. Maybe we need to look into that.
Mm-hmm.
Alex,
Yep.
the question is, you know, in your experience so far, what kind of organization really better fit to using this this system? I understand this is universal, but so far, who showed the most interest? Is it academia? Is it manufacturing organization? Is it research? So what you see actually when you presenting this to the world?
Right. So it's a very, very tough question. But manufacturing is, of course, first, but we need to be very careful about manufacturing. Who is it in manufacturing, right? It's the ones that eventually interested in profitability, efficiency, and competitive advantage, right? So you can think about it that these are the managers, the big managers, the senior executive management that are interested in that, but they are not the direct users of this platform. What we identified lately is mostly QA related processes and people and professions that are the main clients. Because if you think about it, quality especially in manufacturing, it's everything. It's how efficient are, how the process is working, how the product looks like, how do we handle failures, and so on. Everything is about quality today. And probably that's the main goal, and that's the main target market today.
Yeah, I mean it's a good comment. I think, you know, if one thinks how to introduce this to the organization, right? So they need
Right.
to approach a proper people. So you say that quality department would be probably the most promising place to start, right?
Absolutely. Absolutely. I stopped sharing. Yeah, quality department. Again, just think about it. Any problems in quality cost millions and millions especially for bigger organizations. But what does it mean, quality incident, right? It could be incident inside the process, inside the organization. The customer doesn't even see that, right? It could be customer-facing problems. It could be just inefficiencies. But what does it mean, inefficiencies? It's higher cost of the final product. Who is that cost? The end client at the end of the day, right? So quality, it's not only about the actual quality of the product itself, you know, how well it performs, but it's much, much more to that. It's the cost of the processes, it's the efficiency. Of course, it's the quality, it's the quality of the final product itself. It's much, much more to that. We were digging into that lately, and the expenditure for quality departments in the world is just over $14 trillion a year worldwide. Right.
Right. Thank you. A very good presentation, and really very structural approach. So thank you.
Thank you for the comment. All right. If there is no other questions, we will.
Alex, I have a question,
yes.
please.
Of course.
I'm working for a corporation, and there is always a question like, because I'm using the tool and we're using proxy. Sometimes I can open your platform, sometimes I can't. So it's on our side. But
Okay.
In general, there was an impression like I'm posting online some information which might be sensitive, and the managers, they have no idea who accesses it.
Right.
That's a bit worrying.
Yes, I have a very specific answer for that. First of all, we have policies that written on a website about the data protection and data security and who has access to it. Just to give a 2 words answer here, nobody. Okay, the data is encrypted. Even if somebody does accesses it, nobody can read it. It's basically garbage. It's encrypted data. It's encrypted at rest. It's encrypted in transit. Nobody can read it. Sorry, even if somebody does break into the system and somehow get into that and somehow, I don't know, it's going to be useless without the ability to decode. Right.
Yeah, I think
Now,
it's important. Yeah, go ahead. Sorry.
Yeah, go ahead. Go ahead.
No, I say it's important question, but just to clarify it a little bit more, what about AI? So, when you use AI, what kind of model you use, and is it open or is it also protected somehow?
So currently we're using an OpenAI model. We're using multiple models behind the scenes. Depends on the task. But it's all currently OpenAI. We potentially might look into open source models and host them ourselves in the future. That's the future us. That being said, we have a contract with OpenAI. The data is not stored, it's not processed, not used by anything, or they basically not allowed to store it, use it, process it. Right. The only processing is just to provide the answer. That's it.
May I add something? We also have very good button. You click and you disconnect it from AI. Some companies said we have our own AI. It is not a problem to reconnect the platform to their local AI.
Yeah, that's true. So that's another option. So for example, a few companies, they're saying we not even necessarily hosting AI, but we proxying connection. So we have at least some level of controls. That's also fun. So we're trying to give as much control as possible from that perspective.
Okay, thanks.
Yeah, and Dmitry, we can talk more about this if it's a problem. The reason I'm saying that we usually go through audits if needs to be. And
nice.
No problem with that. Yeah. Usually, because we still don't have an official certification in place, we do go through audits and we do go through these checks before we start working, before we onboarding with an organization.
All right, thanks, Alex. Thanks. No more questions.
All right. Cool.
I wanna add just a few words. We have very good onboarding process. We can teach you and teach you guys how to use the platform and help to start to operate.
And the science behind it.
Yeah.
All right. I'll stop the recording.